A palindrome is a word that reads the same forwards and backwards. Racecar, level, noon. You have probably heard of them, but here's the version that actually trips people up in interviews. What about the whole sentence? A man, a plan, a canal, Panama. Ignore the spaces, the comma, the colon, just the letters, and it's a palindrome. So the question is, how do you write code that figures that out without getting lost in all the noise? Before writing a single line of code, let's make sure we understand what the problem is asking. We are given a string. It might have spaces, punctuation, capital letters, all kinds of noise. We need to ignore all of that and only look at the actual letters and numbers. Then, with just those characters, check if the string reads the same forwards as it does backwards. Two things to nail down before touching code. First, what counts as a valid character? Only letters and numbers, no spaces, no punctuation. Second, does case matter? No. Uppercase, lowercase are treated the same. Capital A and small a are the same character for our purpose. The most natural first instinct, clean the string first, then check if it's a palindrome. Strip out everything that isn't a letter or number, convert everything to lowercase, and you have got a clean string. Then just check, does it equal itself reversed? That's a completely valid approach. It's not wrong. Let's build it out and understand exactly what it cost us in time and in space before we look at whether we can do better. Here's what that looks like in code. We start with an empty string called cleaned. We convert the whole input to lowercase. Then we loop through every character, and for each one, we check its ASCII code to decide if it's a letter or a number. Letters A through Z have ASCII codes 97 to 122. Digits 0 through 9 have codes 48 through 57. If a character falls in either range, we add it to our clean string. Everything else get ignored. Once the loop finishes, cleaned as contains only the characters that matter. Now the palindrome check itself is one line. Does clean as equal cleaned as reversed? Split it into characters, reverse the array, join it back into a string, compare, done. Now let's count what this actually cost. The loop through the string is big of n. We visit every character once. The reverse and join at the end is also big of n. It has touched every character in the cleaned string. So the time complexity is big of n overall. But here's the space cost. We built a completely new string, cleaned as, that could be as long as the original input. That's big of an extra space. For a string of a million characters, we are creating a second string of up to a million characters just to check a palindrome. For most cases, that's completely fine, but it's worth knowing because there's a way to do this check without building that second string at all. Here's the key question that unlocks the better solution. Do we actually need to see the whole clean string at once, or can we just check characters from both ends and meet in the middle? Think about what a palindrome check really is. We are comparing the first character against the last, the second against the second to last, and so on, moving inward until we either find a mismatch or run out of pairs to check. We never actually need the full reversed copy. We just need to compare pairs one at a time from the outside in. That's the two pointer idea. One pointer starts at the left end, one starts at the right end. They move towards each other. At every step, we compare what they are pointing at. If the characters match, both pointers move inward. If they don't match, it's not a palindrome. Stop immediately. One thing to handle, the pointers will sometimes land on spaces, punctuations, or other characters we want to skip. The fix, inner while loops. Before comparing anything, the left pointer keeps stepping right until it lands on a letter or a number. The right pointers keep stepping left until it lands on a letter or number. Then and only then we do compare the two characters. This means we never build a clean copy of the string at all. The pointers walk the original string, skipping noise on the fly. Two integers, nothing else allocated. That's big of one space. Here's what that looks like in code. No helper that builds a clean string this time. We go straight to two pointers, left at index 0, right at last index, both pointing into the original string. The outer while loop runs as long as left is less than right. But before comparing, two inner while loops handle the noise. The first advances left past any non-alphanumeric characters. The second walks right backward past any non-alphanumeric characters. Once both pointers are sitting on valid characters, we compare, converting to lowercase first since the original string still has mixed case. If they don't match, return false. If they do, step both pointers inward and repeat. If the outer loop finishes, return true. Now let's count the cost of this version. The outer while loop visits every character at most once. Each pointer moves inward until they meet, covering the full length between them together. That's big O and time. Space, no clean copy, no reversed string, no new array, just two integers variable left and right that exists regardless of how long the input is. That's genuinely big of one space. Constant. It does not grow with the input size at all. So solution 1 and solution 2 have the same time complexity big of n, but the space complexity is fundamentally different big of n versus big of 1. For a string of a million characters, solution 1 allocates a million character copy, solution 2 allocates two integers. That gap matters at scale. Here's the real takeaway, not the code, but the thinking pattern. Every time you see a problem like this, ask yourself three questions in order. First, what's the simplest version of this I can solve? That's your brute force. Get it working. Understand what it cost. Second, what are we computing that we don't actually need? That's the insight that usually unlocks the optimization. Here we didn't need the full reversed string. We only needed to compare pairs. Third, what's the minimum I need to track to get the answer? That's what reveals the optimal space complexity. Brute force first, then question what you are computing, then minimize what you are storing. That sequence works on almost every problem you will see. So, valid palindrome. Two solutions. First, clean the string, reverse it, compare big of and time, big of and space, clear, readable, completely correct. Second, two pointers moving inward, comparing pairs, same big of and time, and the space drops towards big of 1 if you skip the helper. The two pointer approach isn't just faster in practice, it's the pattern that unlocks dozens of other problems. Whenever you are comparing elements from both ends of a string or array and moving inward, that's two pointers. Recognizing that shape is worth more than memorizing this solution.